So glad you asked. The ones we are allowed to omit from topic 5, the differential equations, is you can omit 4 and 6. You can omit 4 and 6.
Happily.
Yep. Again, if there's one of these that you're struggling with or want more practice on, all the answers are posted, so you're welcome to try them or just sketch them a little bit and see how you're doing.
Which ones are we going to do in class today?
So today we're going to do 1 and 2. And so that will leave you with 3 and 5. All right, so 1 and 2. Number 1 is among calculus people, I'm going to say it's a famous problem. Like, you've never seen the problem before. But among calculus teachers, if you say something about the potato problem, this is what everyone knows. This is the one that, like when students come out, they're all talking about, and then in nerdy circles of Twitter and Facebook, potato problem starts trending, and so every year there's like one problem that sort of becomes, not even every year, but number 1 is one of those, and the baby bird problem, number 5, is again calculus famous. So like
common.
It's not famous, worldwide famous. Among calculus teachers, it's famous. All right, so number 1, the potato problem. At time equals 0, a boiled potato is taken from a pot on a stove and left to cool in the kitchen. The internal temperature of the potato, and I guess some of these gain their legendary status because they're associated with an actual situation. Yeah, like look at number 2. There's nothing, that's not like an application problem. That's more straightforward stuff. So that one has less of a chance of becoming famous. But the potato problem, here we go. Anyway, the internal temperature of the potato is 91 degrees at time 0.
Celsius? Jeez. What?
So I'm already thinking a table of information here.
Because it tells us H.
And H is the temperature. I guess to avoid
the internal temperature.
T and T, using 2 T's. H is our temperature. The internal temperature of the potato is greater than 27 for all times T greater than 0. The internal temperature of the potato can be modeled by this differential equation. dH dt equals negative 1/4 H minus 27. Where H is in degrees. And they sort of re-emphasize this for us, that H of 0 is 91. They gave us that twice. Must be important.
Like a teacher saying something twice right before a test.
Part A. Write an equation for the line tangent to the graph.
Point and slope.
Yep, tangent line. So yes, I'm already thinking point and slope. At t equals 0.
Wonder why they said it so many times.
Okay, so now I know why I've got 0.91. Use this equation to approximate the internal temperature of the potato at time 3. Okay, so point is 0.91. That's why they gave that to us twice. But I need the slope.
They gave us the slope.
What's the slope?
Negative 1/4.
Yeah, slope is dH dt. So they gave us a formula for that. So negative 1/4. What's H?
0.
Careful.
3.
What's H? At this point,
91.
H is 91. Let's see. 91 minus 27.
Is it calculated? It's no calculator.
It's no calculator. So I could leave this as my slope.
Not touchy. And label it as something if you want to.
You could do that. You could call it M and then just use M the rest of the way. Except that you're going to use it to estimate. Well, I guess you could still have M as part of your answer.
As long as you label it.
I'm going to go ahead and subtract because I see what they did here. They made it work out. 91 minus 27 is 64, and 1/4 of 64 is negative 16. So you don't have to reduce it, but I don't know. I think it's worth it. So tangent line. I don't know if I want to use y. I think I want to use h. H minus 91 equals negative 16 times t minus 0. There's my tangent line. Okay, so that's the first part of the question. Use this equation to approximate the internal temperature at time 3. So, how do I do that?
Substitute.
What for what?
T for 3.
So, at t equals 3, h equals negative 16, 3 minus 0, plus 91. And that's like the end of the problem, so I'm going to leave that. I feel like I simplify if I know I'm going to need it more later to just make my life a little easier. But if that's the end of the question, then leave it alone. Although you might want to see if it makes sense. 91 minus 48 is 43. I guess that makes sense. It's decreasing because you took it out of the boiling water and set it in the room.
Yeah,
it should always be more than 27. So
3 minutes after, yeah.
Okay, reasonable enough.
Potatoes don't have a very high specific heat.
Use the second derivative
Take a second derivative?
to determine whether your answer in part A is an underestimate or overestimate. So second derivative is about concavity.
Mm-hmm.
So I'll need to know if my Alright, so if I'm concave up versus concave down, but I need a second derivative.
Take a derivative of dH.
So I need a derivative of dH dt.
Which is up there.
So you could leave it as is. It might make more sense to distribute the negative 1/4, especially when it comes to a derivative. So negative 1/4 dH dt. Yeah. Plus 0. So there's my second derivative.
Times our dH dt.
Use that to determine. So let's find dH dt, the second derivative though, at 0. So negative 1/4. dH dt at 0 we already found. That was, if you, negative 16.
Well, they made it work out.
So they made it work again. But more importantly than the number 4 is that it's positive. Because they didn't tell me to find it. They just said use it. Which means, I guess I need to find it. But I think that's sort of code
you
for...
didn't really need to find it. You just needed to...
I just need to know that it's positive.
Figure it out.
Okay, so if H is concave up, the tangent line is...
It's an underestimate.
Right, I got my pictures there, so I don't memorize this stuff. I just draw a picture when I need it. If H is concave up, then my tangent line is below the curve. So my estimate is an underestimate. So the estimate in part A, I guess I could just say the estimate is an underestimate. I think you see why this one got famous for being hard, basically. Part A was supposed to be easy, so you should have got part A. Part B, well, okay, a little shakier, but like the math really wasn't that bad. Part C, for t greater than 10, an alternate model for the initial temperature of the potato at time t follows this equation. Right, this is the last part, so we're expecting this to be ugly. Let's see. Where G is measured in Celsius, G of 0 is 91. Oops. T, G. Find an expression for G of T. Find an expression for G of T.
Integral.
I'm going to have to integrate to get G. To undo the derivative, I've got to integrate.
Which is so much fun.
So that would be dg equals, moving things around, move the dt over,
Is this one of those?
g minus 27 to the 2/3 in the denominator. That's yuck. I'm separating variables. Almost always that gets you 1 point, so that's probably worth the point right there. Because you're like, okay, I know what I'm supposed to be doing. Now let's see if I can actually do it. Then we can integrate both sides. Now I know why they gave me this initial condition. I will use that in a moment.
C1, no.
So let's see. Increase the power by 1. Divide by the new power. On the other side, it's just negative t plus c.
Yeah. Probably plus C.
Okay. Well, I mean, that's not a terrible integration. You just had to recognize that's what you had to do. And then I need to plug in 91 and 0 to figure out what C is. I could solve for G.
I would solve. No.
I think I would just plug it in. What's that?
I'm trying to figure out which one you'd solve for first.
I mean, you could solve for G, but that would be a mess. Let's just plug it in.
Oh, okay.
0, 91. So 3, 91 goes in for G. 0 goes in for T. So that was a good choice. I can figure out what C is right away. You could leave C as that, but
It's no calculator problem.
because it's no calculator, but I'm going to have to use that in a minute. So 91 minus 27, we already did that. 64. Oh, they're just throwing me bones all over the place here. Like, how kind of them. Because the cube root of 64
16. No.
is 4.
Oh, right.
And again, I could leave it like this and then have an answer that includes that, but they've done me a little bit of a favor here. So C is 12.
Yay.
And we want to know, find the temperature at time 3.
So we still have to solve for G.
We will, although I'm going to go ahead and plug in T equals 3. So 3 times G minus 27 to the 1/3 equals negative 3 plus 12. Get my face out of the way there. I think they've done us another favor here.
You think?
Let's see. Negative 3 plus 12 is 9. Divided by 3 is 3. Running out of paper here, running out of space. Then cube both sides. So they gave us a reasonable number to cube.
Because it's 27, right?
It's 27. And then add 27 to both sides. So G is 54.
And that's what we want, right?
And our previous estimate was
40 something.
40 something, 48. Did we even figure that out? Or 43?
Yeah.
Anyway, we're in the ballpark. It started at 91. It's cooling down. So 3 minutes later, it's at 54. That seems reasonable.
Not too bad. Yay!
the potato problem in exactly 15 minutes.
Nice. Let's go.
Yeah. I don't know what else to say. That's the...
Do we have time for number 2?
They time them out right. Yes, we do, because we get out at 58, and it's 42. So, yes.
We'll have 2 minutes.
I will have 1 minute remaining. Number 2. Consider the differential equation.
Differential implies continuity.
X squared minus 1/2 y. Find the second derivative in terms of x and y.
Oh. How lovely.
That seems fairly straightforward. Straightforward enough for me to press pause and give you a chance to do it. Left off somewhere up here when I had you guys find that derivative.
Yada, yada, yada.
Then we did relative max, relative min. Press pause if you want to see it. Now we're down to part C. L'Hopital, L'Hopital, L'Hopital. Well, actually just twice. The derivative of 6x plus 6, I think I would just distribute that. Derivative would be 6. Okay, so I'm not getting 0 in the bottom. So no more L'Hopitals.
And they gave us G double prime.
And did they give us G double prime?
Yeah, because they had us take the second derivative.
Yeah, they had us find the second derivative. So the second derivative is the second derivative at -1, 2. Second derivative, way up there at the top, is 2 times x minus 1/2 times dy dx. Didn't we just find dy dx?
Yeah,
That was 0.
So -2.
So -2 is the top. So -2 over 6. -1/3.
Yay!
Wow, that was a...
And we still have one more part.
But L'Hopital, L'Hopital, L'Hopital was that. Okay, so we did not learn Euler's method because that's a BC part. So
We can ignore that.
we can throw that part out. Which means if that was a common question, they would have like repointed it. Like 3 of the questions are common between AB and BC, but BC does Euler method.
Yeah, 'cause
and we
Mr.
do not.
Conley mentioned it too.
Can I see that? On the first multiple choice in packet, it says like the curve passing through 2 and 0 without applying the differential equation. You have to find an approximation using Euler's method. Is that like why I did not know how to do that?
Yeah, you can, anything you see with Euler method, you can throw out. That's a BC topic.
Yeah, just saying.
So that multiple choice question is out. It's also why I threw out one of the ones from today.
They're using that same principle, like if you're on the AP test, you just throw out whatever you want.